Let's take a look at solubility, or how much can dissolve a particular substance in a solvent. So the typical units that we look at for solubility is the grams of solute in 100 grams of solvent, although there are other measures you may see of solubility. It's also important to keep in mind that the temperature is really important for solubility. We'll look at how that affects solid solutes versus gaseous solutes, so whether you've got a solid or a gas dissolved in a liquid. We also want to look at these terms of saturated, unsaturated, and supersaturated solutions. A saturated solution has as much as is possible dissolved in it. And you can tell this by looking at the solution, because typically you've got a solution that's saturated when, if you add more of that solute, you could get a solid substance at the bottom. So notice that there's a precipitate of that compound at the bottom of this beaker. So we've got a saturated solution above and extra precipitate that's falling out of the bottom. An unsaturated solution just has less than that amount. So it's less than the saturated. So you could add more of the solute into the water here, and it would dissolve. A supersaturated solution is a unique type of situation. It's actually surprisingly common, where a solution has been heated, typically, so you have, or cooled depending on the type of solution, and it's gone. So like for a salt solution, or a sugar solution, you've heated it above normal room temperature, dissolved more solute in there than you would normally be able to dissolve, and then you slowly cool it down, and the salt or sugar or whatever is dissolved in here will stay in the solution until it's perturbed in some way. This is actually kind of part of how you make candy or other substances where you've got a lot of sugar that's dissolved in water. But there's a lot of different solutions that are used with supersaturated. So supersaturated solutions, they're not super common, but you may encounter it. So just be aware that that's got more than is normally possible. So let's take a look at how solubility is affected by temperature. So we have the milligrams of gases dissolved in 100 grams of water. And notice that as the temperature increases, that the solubility of the gas goes down. It decreases as the temperature increases. And you can think about this as the soda going flat effect. If you have a soda that you leave out, as it warms up, it's going to have less of the gases dissolved. The solubility of solids, on the other hand, so this is gas, solids, you'll notice that the solubility increases as the temperature increases. So you can dissolve more of a solid as you heat up the solution. This is common with it, so that doesn't matter whether it's glucose, so sugar, various salts, so potassium iodide, potassium nitrate. So remember, all ionic compounds are salts. Sodium chloride even increases slightly. It's pretty stable across its temperatures, which is why we use it for so many experiments. That's why it's such a good salt to use for different things. But overall, you can see that the solubility increases as the temperature increases of the solution. Now we also, when we're looking at solubility of solutes, we need to take another look at gases. So we want to look at pressure. So this is related to the pressure of the gas. So at a higher pressure, more gas dissolves. So this actually can help us to understand why sodas are in enclosed cans that are kept cold. Because if you close the can or bottle, you can keep the gas at a higher pressure. More of the gas will dissolve, so more carbon dioxide will dissolve into the solution, making a fizzier beverage. If you also keep it cold, then more gas can dissolve. So you combine those together and you get a very fizzy beverage. If you open the bottle, that's going to decrease the pressure. You're going to get the fizzing. If there's enough of a pressure change, the gas escaping can take soda with it. For the solubility of ionic compounds, make sure and review your solubility rules. So, make sure and look at those and how we determine whether a particular ionic compound is soluble in water or not.